Hello everybody, welcome to Tubi. So today we will be doing trigonometry. So trigonometry means measuring triangles. What we will learn in trigonometry is to get to know all the sides of a triangle, and it's not only about triangles, it's much more. So let's get started. So first we need to know is about trigonometric ratios. So when you take a right angle triangle, as you can see, all the ratios of the sides will be same because all of them are similar triangles. This will be 90 degrees, and if you keep this angle as theta, theta is a Greek letter to keep angles. So if you keep this angle as theta, then this will be 90 minus theta. This also will be 90 minus theta. Therefore, these two triangles are similar. Therefore, their ratios will be same. So for a specific angle, the ratio is always fixed. So using that, we have many uses of trigonometry. So as you can see here, there are three main trigonometric ratios. One is sine, which is abbreviated as SIN. The full is SINE. Next one is cosine, which is abbreviated as cos, and full is cosine. Next one is tangent, abbreviated as tan. So sine is the opposite side by the hypotenuse. So the opposite side of the triangle divided by the hypotenuse of the triangle. So that gives you the sine of the triangle. Next, cos is the adjacent side divided by the hypotenuse. Then the tan is the opposite side divided by the adjacent. So in this case, they have taken the angle to be this. So this will be the angle. So here they've taken the angle. So this is the adjacent side, this is the opposite side, and this is the hypotenuse. So there are three more reciprocal trigonometric ratios. So there is secant. So secant is equal to 1 by cos, and cosecant is equal to 1 by sine, and cotangent is equal to 1 by tan. So these three are called as the reciprocal trigonometric ratios because they're each of them other trigonometric ratios reciprocals. So as you can see, secant is hypotenuse by adjacent, cosecant is hypotenuse by opposite, and cotangent is adjacent by opposite. So these are always fixed for a certain angle. So here are some standard angles for which the values are given. So as you can see, sine of 0 is 0, sine of 30 half, sine of 45 1 by root 2, sine of 60 root 3 by 2, sine of 91. And cos, if you see, it is the exact opposite. So here 90 1 0 0 0 1, and 30 sine is half, cos is root 3 by 2. 60 sine is root 3 by 2, cos is half, and 45 both are 1 by root 2. Then tan is sine divided by cos. So that one you need to keep, that tan of an angle theta is equal to sine of that angle divided by cos of that angle. So you see, it comes out to work here also. So if tan is this, then cotangent will be equal to cos theta by sin theta. So as you can see, all the ratios are here, and as you see, the tan of 90 is not defined. So nd means not defined because the sine of 90 is 1. So tan of 90 is equal to 1, and cos of 90 is 0. So 1 by 0, and 0 is in the denominator, so it is not defined. So let us just solve a triangle here. Think this is a triangle with this angle equal to 30 degrees, this side equal to 5 units, and this is 90 degrees. So now they ask you to find the rest of the sides and the angles. So this you can use the angle sum property of triangle to figure out it is 60 degrees. So now let us find out the hypotenuse. So as you know, cos of 30 is root 3 by 2. So root 3 by 2 is cos of 30. So and what is cos of 30 equal to? So cos of 30 is equal to adjacent by hypotenuse. So root 3 by 2. So cos of 30 is equal to root 3 by 2 is equal to adjacent by hypotenuse. So in this case, root 3 by 2 is equal to adjacent is 5, so 5 by hypotenuse. So let us take reciprocal on both sides, so it will come 2 by root 3 is equal to h by 5. So hypotenuse is equal to 5 2 5 into 2 by root 3, so which is equal to 10 by root 3. So let us write it here. So the hypotenuse is 10 by root 3 units. So now as we know the hypotenuse, we can figure out the opposite side either by Pythagoras theorem or because we are doing trigonometry. Let us use tangent. So tan of 30 degrees is equal to opposite by adjacent. So tan 30 is equal to O by A. So in this case, tan of 30, as you can see here, it is 1 by root 3. So 1 by root 3. So 1 by root 3 is equal to opposite is O and adjacent is 5. So if you want to find out O, so opposite side is equal to 5 by root 3. So it's very simple. So 5 by root 3. So now we have found out all the three sides and all the angles of this triangle using trigonometry. So radians is another way of measuring angles. So 2 pi radians is 360 degrees. So we should go anti-clockwise in this case. So 2 pi radians is 360 degrees, and that's how the 2 pi r formula of the circumference of the circle comes. So 2 pi radians is 360 degrees, and pi radians is obviously 180. Pi by 2 radians is 90. So like this you can use the unitary method, or you can use just normal ratio proportion to get to know the degrees to radians conversions. So for example, if you want to do 30 degrees, so 30 degrees is how many radians you want to find out. So as you know, 360 is 2 pi radians. So 30 is how many radians? So the answer will be 2 pi by 360 into 30. So 0 0 cancel, and this becomes 1, and this becomes 12, and 2 gets cancelled, and this becomes 6. So 30 degrees is equal to pi by 6 radians. So radians is written as RAD for short form. So pi by 6 radians is equal to 30 degrees. So like that you can find out the angles in degrees and radians. Next, this is a unit circle. So unit circle is the circle with radius equal to 1 unit. So the radius of the circle is 1 unit. So and this is our angle theta. So as you can see, the sine of this angle is nothing but the y coordinate. So y coordinate is the sine of the angle. So sine theta is equal to y coordinate, then the cos theta here, as you can see, is the x coordinate. So cos theta is equal to x coordinate. So when you take this point, the tan theta, so the tan is equal to sine by cos. So sine is the y coordinate of this point, and the cos is the x coordinate of this point. So tan will be y by x, which is nothing but slope. So tan theta is equal to slope of this line or this point. So tan theta is the slope of this point with respect to the center point. So from here you can get to know the other ratios also. So this is the secant of the angle, and this is the cosecant of the angle, and this is the cotangent of the angle. So using the unit circle, you can get to know the sine and cos and tan of many degrees, like 180 degrees. So 180 degrees, if you take the x coordinate is equal to -1, y coordinate is equal to 0. So the cos is equal to -1, sine is equal to 0. And if you take 270 degrees here, 270 degrees, then the x coordinate is equal to 0, y coordinate is equal to -1. So cos is equal to 0, sine is equal to -1. So here are some trigonometric identities. So for example, these are the reciprocal identities which we did. And here, as I told, sine by cos is equal to tan and cos by sine is equal to cot. And these are some identities called Pythagorean identities. These come out of the straight from the unit circle. You can check it out if you want. So as you see here, this is sine, this is cos, this can also be written like this, and this is 1. So when you make a triangle out of this, sine square plus, so when you make a triangle out of this, sine square plus cos square is equal to 1 square, which is 1. So you get sine square plus cos square is equal to 1. So next, these are complementary angles identities. So as you can see, sine of theta is equal to cos of 90 minus theta. So you can just take a triangle and try it out. This will be theta, this will be adjacent, hypotenuse, and opposite. So if you take sine of this angle, then you will get opposite by hypotenuse. But instead of this is 90 minus theta. So if you take this as theta, so if you take 90 minus theta as theta, then the cos of that angle will become O by h, which is nothing but the sine of this angle. So sine of theta is equal to cos of 90 minus theta. This is another simple identity. So like that, there are cos theta is equal to sine of 90 minus theta, tan theta is equal to cot of 90 minus theta, cot theta is equal to tan 90 minus theta, and two more are there. And these are the identities of the sum or difference. As you can see here, sine of alpha plus beta is equal to sine of alpha cos of beta plus cos of alpha sine of beta. So this is another identity. Then here, as you can see, a reverse thing is given. So this means whenever here the positive comes, here negative should come, and whenever here negative comes, here positive should come. And in this case of sine, whenever here positive comes, here also positive should come. So as you can see here, in the case of cos, so cos of alpha plus beta is equal to cos of alpha cos of beta minus sine of alpha sine of beta. So it up So for tangent also there is. So tan of alpha plus beta is equal to tan of alpha plus tan of beta divided by 1 minus, because here it's in the reverse, 1 minus tan alpha tan beta. So these are some sum and difference identities. Then there are some double angle identities, as you can see here. Sine of 2 theta is equal to 2 sine of theta cos of theta, and half angle identities also. And there are product identities also, like sine of alpha cos of beta is equal to half of sine of alpha plus beta plus sine of alpha minus beta. And these are all the identities which are there. So trigonometry can also be used in non-right angled triangles. So here is the law of sines. So law of sines is that, so sine of A by this side A. So here capital A is the angle and side A is the length of the side. So sine of A by A is equal to sine of B by B is equal to sine of C by C. Very simple to remember. Sine of the angle divided by the opposite side, all of the three are equal. This is the law of cosines, which says that the square of this, the third side square, will be equal to the square of the one side plus the square of the other side minus 2ab cos of this angle C. So this is the law of cosines. You can use it to find this side C, the law of cosines. So law of sines also we can use it to find the angles and the sides length. So these are some inverse trigonometric functions. So example, we give that there is a triangle. We give the opposite side as 8 units, and we give the hypotenuse as 13 units. So we ask you to find this angle theta. So what is this angle equal to? So take sine theta. So sine of theta is equal to opposite by hypotenuse. So 8 by 13. So what will the angle theta be equal to? So angle theta is equal to the sine inverse of 8 by 13. That's what is given here. So cos inverse of theta is equal to x is equal to cos of y. Sine inverse of theta is x is equal to sine of y. Tan inverse of theta is equal to x equal to tan of y. So this is how we use inverse trigonometric functions. So these are the graphs of the trigonometric functions. So the graph of the sine function is like a wave. So that's why these are wave functions. And as you see, the sine function starts from 0. So the sine function starts from 0, whereas the cos function starts from 1. So at x is equal to 0, the cos function is equal to 1, and the x is equal to 0, sine function is also equal to 0. So when x is equal to pi by 2, which is 90 degrees, the cos is equal to 0, whereas the sine is equal to 1. So it seems like a shift of pi by 2 between the sine function and the cos function. And this is the tan function. So tan function goes like this. And as you see here, it pi by 2 degrees, the tan function is not defined. So it keeps increasing till pi by 2, then it decreases. So the pi by 2, it is not defined, the tan function. So there are some properties to the graphs of these functions. The period is the x coordinate taken to go from here to here. So in this case, this will be the period if you take from here to here. or that will be equal to, if you take like this, so this is one complete cycle. So start and end. So one complete cycle is the period. So the amplitude is the height from the mean distance. So the mean distance is this. So the mean distance will be the highest point plus the lowest point divided by 2. And this is the amplitude. So this is the amplitude and this is the period. So if we take a function like f of x is equal to a sine of kx. So kx. So in this case, the period is equal to 2 pi by k, because 2 pi is the period of the normal sine function. So y is equal to sine of x. So the period of this function is 2 pi. So the period of this new function will become 2 pi by k. And the amplitude is equal to a, because we are increasing in the y direction by this amount. So the amplitude is a and the period is 2 pi by k. So there are two more properties, which are the vertical shift and the phase shift. The phase shift is also the horizontal shift. So vertical shift is how much it is shifted upwards or downwards, and the phase shift is how much it has shifted left or right. So if we write a function like a sine k into x minus p plus h, this is how we usually write a sine function. So in this case, the period will be 2 pi by k, the amplitude will be the a, the vertical shift will be h, and the phase shift will be p. So here plus h is there, here minus p is there, that one you should remember. So if h is positive, that means it is a sine of k into x minus p plus h, then it goes upwards, the function shifts upwards. And if h is negative, then the function shifts downward. And if p p is negative, remember it becomes k into x minus p, which is k into x plus p, then it shifts to the left. And if p is positive, it shifts to the right. So if it is positive, it becomes k into x minus plus p, which is k into x minus p, so it shifts to the right. So some uses of trigonometry. So when we can use trigonometry to decompose a vector into its constituent direction. So here is the x direction and the y direction and the resultant vector. So this is the final resultant vector. Compose it into its constituent y and x. So what happens is the fy, so the y direction of the vector will be equal to the magnitude into sine of this angle A, and the x direction will be equal to the magnitude into the cos of this angle A. And as you can see here, it is also used in wave functions. So in periodic functions like oscillations or sound, or even many complex periodic functions, the trigonometry is used. It is also used to measure heights and angles, and it is also used in many more cases. So here are some bonus questions. So let me analyze this question. So this is the top height of this cliff. So this angle is 20, this angle is 25. You can use a calculator to find the trigonometric ratios of these two angles, and you need to find out the height h and this distance x. So this should be an easy question. So try to solve this and let me know the answer in the comment section. And this is another question. So this was the original point in y is equal to sine of x. So was the first 0 point before I shifted the function. So before shifting the function, this was the original point. No, so in this graph, so you should find out the functions period, amplitude, phase shift, and the vertical shift. And you should write the equation for the graph of the function in terms of a sine function. So as you can see, you should write it in this form. Thank you everybody for watching our video, and please subscribe to get more videos like this, and you can press the bell icon to get notified whenever a new video releases. Thank you.